Hello. Uh, so apparently no introduction. The whole motivation for this talk initially is I'm kind of annoyed at bad monad talks. So hopefully this is a good monad talk. Um, so yeah, well, hopefully this goes well. So here I am. My name is Gina Banyard. My pronouns are she, her. I studied mathematics, pure mathematics at Imperial College London. I'm a PHP core developer, financed by the PHP Foundation. If you do finance them, thank you. If not, why not? I am also the lead maintainer of the French translation, which is not very relevant to Dutch people for the most part and others. I care about type systems, and I care about PHP semantics quite a bit, so I can rant about weird PHP stuff does for ages. I don't have the slides yet on my website, but I will try to upload them as soon as possible. And you can find me on Mastodon at geargears and phpc.social, or also on Twitter, which I barely use, at geargears. So yeah. So before we starting, so monads is a concept in functional programming. And functional programming is a very different way of programming in general. And the core essence, or some of the core essence of functional programming are pure functions. And pure functions are functions that have no state, do not cause side effects, and produce the same result given the same inputs. So if you add, like the add function here, is a very pure function. Like you take 1 and 3, and you add them together, you always get 4. It doesn't do anything else, it always returns 4. Some impure functions are fget, so you get the same file and you get different lines. So same input, different output. Array rand is same input, also completely different values depending because it's random. Sort is also an impure function in PHP specifically because it takes the array by reference and it modifies the parameter. So yeah, and this leads us into the second point, is that in functional programming, values are immutable. So you can't actually modify them how we usually do them in PHP, like reassign variables and stuff like that. So the natural consequence of this is that you don't actually have loops in functional programming, because obviously if you do like a normal for loop, you increment a counter, which gets checked against the condition at every iteration, and then you do something in the loop and you redefine the variables in general. Or like in a for each, you might append to an array multiple times to like track the state of your loop and everything. So the way that it gets done, like how do you do loops in functional programming, is basically recursive functions. So here is a example that I came up with, which takes a product, and like a list of products, and returns the prices of these products, considering they are objects. And yeah, so you go through, if you have passed the maximum index of the array, you return the empty array. And otherwise, you get the product price, which is however it works, and you return this you append this into the array. And the same way, it's like, in the meantime, before you append the thing, you get the previous prices, and you like splat out the values of the array. So yeah, all right, I need to click that. So in functional programming, you need to pass everything by parameter. And I mean, I don't know about you, but like a lot of state is usually passed around that is implicit. And even so, like we try to pass state into classes, so we do like dependency injection and everything. And so the way to actually do this in functional programming is you actually, you bind data to the function. And how one way to see this is, instead of binding functions to data in the way like a class normally does it, is that you bind data to a function. So for example, from the previous example, the add function, I take the add2 function, which takes one parameter, an integer, and which basically binds or wraps around the add function with one value preset. This is also called partial applications of functions. So we partially apply the add function with one parameter set to 2. And for example, we could have all of the attendance of this conference, and I can say, well, I want to find the DBC attendance. Well, I filter by the attendees and I already set like the value to what I want to filter by, which is DPC. So yeah. Now, in an ideal world, you would just pipe functions together from like your data. So you get a user via an ID, for example. You get a cart because it's a shopping software defined for this user. You get the products in this cart. You get the price of this cart, like you have the price of every item. So you add up the price of each item. You charge the amount, which like the credit card vendor, and then you dispatch the products to the customer. The sad reality is that a lot of places can go wrong. For example, well, what happens if you don't have the user? What happens if one of the products actually sold out and doesn't exist or has been discontinued? What happens if like there's a discount with the price and everything and the discount is not valid? Like there are multiple ways where stuff can fail. But the problem is like how can you have state and how can you have all of this error logic handling and different branching behavior and everything when you are not allowed to have state in a pure functions and all of your values are actually immutable? Like how do you navigate this? So the solution is actually a monad. Now, what on earth is a monad? Well, this is a definition from Wikipedia. So monads in category theory, which is a branch of mathematics. And a monad is a monoid in the category of endofunctors of some fixed category. A monad is an endofunctor together with two natural transformations. What on earth am I talking about? Like, what on earth is a monoid? What on earth is a category? What on earth is an endofunctor? And what are natural transformations? Turns out, for the sake of programming and the sake of functional programming, you don't actually need to care about this definition. People like to throw it around to be fancy, but in programming, a monad is a structure that combines functions and wraps the return value in a type with additional computations. Monads define two operators. One to wrap a value inside the monad, which is called the unit, and another to compose together functions to output values of the monad type. So yeah, that's also picked from Wikipedia, but monad in functional programming. So what it actually means in practice. So a monad M is a wrapper around some data of type T, and I'm going to use the bracket notation, so M of T, which has two associated functions. So like I said, like the unit or return function, you will also see it called, which takes a value of type T and returns you a value of M of T. So just wrap, his whole point is wrapping the value. And the bind function, which takes a callable, which returns a monad, where the callable takes the value of type T and returns you a monad, the same monad of type S, like inside of it. So yeah. Now I'm going to do the ubiquitous example, which is the maybe monad. I don't really like the maybe monad. It's kind of boring, but it's a good place to start. So here is one implementation of a monad, like a maybe monad. That's not the unique way of implementing it. It's just, it takes one value, so I have my function unit, which creates a maybe monad by just creating a new object and setting data to the data property. I have an is-nothing function, which basically checks if data is undefined or not. This is just a weird PHP trick to check if the value is null, or like not null, like undefined, because isSet will tell you it is not set if your data is null. But that's just like an implementation detail, basically. And what the bind function does, which is the interesting bit, like the interesting bit of monads is like the bind function, is if my data is null, like is nothing, so it doesn't exist, so I have no data, then just return nothing, or like this maybe monad, which has nothing. Otherwise, call this function with my associated data. That's basically what the maybe monad does. So yeah, so let's see it in action. So I'm just going to define a product class, which takes a price. I'm going to take a get product, which if the ID is even, then it returns you an actual product. If not, it it doesn't exist. This system only likes even ID numbers. And then I have a function getPrice, which returns the price for the given product. I apply taxes like VAT or whatever, which is like 20%. And then I have a helper function which mabifies a function which returns a pure result, which are there above. So I take my input, and then I wrap my function in a monad so it returns a monad. So I get my function, I apply the input, like I return basically a closure of it. So yeah. So our initial monad, so get product, like we have like the get product, and we bind our so the get product would return like a maybe. So either I have an ID, either I have like a product or not for the given ID. And I bind it with my maybe pure function get price. So if it exists, get the price. And if it doesn't, well, do nothing. And the same with the the apply taxes. And then I just dump the value if it exists. So if you run this with, like if you would run this code with an, oh, I got my logic wrong. That's good. So if the ID is even, actually doesn't exist. My bad. But then you would just get nothing. So it would basically like skip all of the computation that you're doing, and it would just return nothing. And it would actually compute you the price of if the ID is odd. Like for example, yeah, it's like the price is 20, apply the taxes, done. And you could chain this with way more functions. You could bind this ad infinitum if you wanted to. Now you wonder, Gina, why on earth am I doing this? Like, why not that? Why not just have a function, like just construct my product with an ID, I apply my taxes to my product, I have a DB and I just get the product, and if it exists, give me the product, otherwise just return null. And I do like, well, the final price is like just get the product and then do the like null chain operator, apply the taxes and just give the price of the product. Like, why not that? That's just simpler. So the main thing here is that you're like relying on state. I don't know if you like want to like test this, it gets quite difficult because you need to mock the database, you need to mock like what happens to the applied taxes. Like you already need an object, you already need a product to apply the taxes to. You can't just do the computation like numerically, like with integers and everything. So that's the main reason why this is less than ideal in some situations, because you like everything is tied to the product class instead of being its own standalone thing, which is easier to test. But again, I can totally understand why you would prefer doing this. It is simpler. But also, like I said, the maybe monad is kind of boring. So let's talk about a more interesting monad, the ida monad. So the ida monad actually wraps two values. So we call them left and right. And I'm going to use the notation, so E of left and right. So left, which holds a value of type L, and right, which holds a value of type R. So we have two units instead of one, which creates a case for both. So either I instantiate my left part of the monad, or I instantiate the right part of the monad. So the bind function will unwrap the R value, the right value, if it exists, and pass it to the given function if it's set. Otherwise, left is returned. So basically what I mean is that, like, well, my bind function takes, so the function which I want to pass to bind takes an input of R1, and then it gives you me a new ida monad, which has a left type or a right type, the second one. And so yeah, and the bind function B of F is basically I get a monad, like an ida monad, which has type L1 or R2. Oh, right, that's a typo. My bad. OK. I wanted to say a type of E of L1 or R1, not R2. And what it outputs me is either an ida monad of L1 or L2 on the left side, and I have the result of the function on the other side if it actually was existing. So here's one way to practice, like to implement it again. In general, we call the left the error bit and the right the OK or success case, because if you do error handling, this is what it actually corresponds to. You could use the error, like the ida monad in different contexts where like if you would want it to shortcut as fast as possible for it to be the success. But I don't really have practical examples. The only examples I found out about like are logic puzzles and stuff like that, which is not super interesting. So left and right are my two units for either case, which is like, well, give me a value which is set to left or which is set to right. And the same thing as the is nothing case from the maybe monad is just check if the right bit is set or not. And the bind function is very similar to the maybe monad. It's like, well, if I have the value in my right side, if it exists, well, then call the function and return that. Otherwise, return this was my current error already. So let's imagine a more complicated setup. So we have a file class, a file type. We have like possible error cases, what happen when you try to open a file, like the file does not exist. You don't have the access to it, like the permissions. And now what you're trying to read is actually a directory. So our open file could either return left of an error. So in this case, I would say, like, let's say font does not exist, or either right and give me a new file. So yeah, let's get to the second step. Okay, let's say that like you can't read the error for some, like you can't read the content of the file for some reason. Like maybe the file is actually on a network drive, and you're trying to read it, and like it crashes out, and like you actually have a valid file, but like you can't actually read the content. So if it doesn't, oh, I forgot to update. Second slide mistake. So imagine instead of open file errors, there to be get content errors and file not readable. I apologize. I was tired. And if it does, let's say like you get the content of the file, if you could read it, and it's stored in the right side of the item monad. And let's say like what you actually want to do with the file is like some tabular data, like let's say a CSV thing. So you're trying to like pass a CSV file, and let's say like you get to an unexpected end of file. If you use like an enclosure, which is like these quotes, which is a fun CSV file, or if you have inconsistent line fields, for example, one line has only 2 and another has 4, and you don't really know how to represent this, you could like show this error. And like new function, pass content into tabular error, and either return the content or return, let's say, like a new class which has the data in a tabular form. So the way how you would operate on it is, well, you open the file, and you get like a monad, you get the item monad, and you bind the get content file, and to which the result you bind the pass content into tabular. And at the end, you do your data and you check, well, if my data is right, well, then I have some data. Then I can actually do something with it. And I can continue doing it. But if not, well, I must have like some error. And the nice thing of this is that like your error handling is all pushed outside. It's pushed to one place. Like here, you're checking for all of the errors at the single place instead of maybe having a try catch at a specific place and locally. So like let's say here you want to translate the error into like a number or like a message that you can display to the user. So you can use match and match on the type and do all that, just very handy dandy. And the maybe monad is in some way a specialization of the either monad, where your left side is always null. There is also an exception monad, where the left type is always a string, which is the error message that you get. So instead of using something a bit more abstract, like an enum to handle my errors and then tell what I want to do with them, I would have the actual error message already encoded into my monad. Oh, right. I was already saying this. So the either monad basically is very generic. You can do a lot of stuff generically with it. And it effectively wraps a union type of 2 types. Like either have an enum of something, or I have my result in how I implement it. If you would have the exception monads, like, well, either have a string or have my result, like my data type. And maybe it would be like, well, I have a nullable type, basically. But monads are not just about error handling. Like, that's the most introductory way of presenting them, because it's pretty handy. Like, I can just bind all of my functions in a row. I could bind my functions even more with the tabular data, which I have, and just continue and check all of my errors at the end, which is either all of my pipeline, all of my functions which I binded and piped into the initial call work, and I get my final data and final result, or I have an error somewhere along the way, and I can tell which error it is. But like I said, monads are not just about error handling. Turns out, you use a monad every single day. So lists, or array, how we call them kind of in PHP, are actually a monad as well. So if you have some specific functions associated with your list, then it can become a monad. Now, the nice thing about the list monad, it allows us to rederive the kind of original categorical definition with the like two natural transformation things and like whatever. The reason for that is because list is a functor. So very confusingly, a functor is not a function. Well, a function is a functor. But a functor is a type, a data type, on which you can map over it. So a list you can, well, in PHP we have array map, where you can just map over my data structure. So that basically what makes it an applicative functor. And the two natural transformation of like a list is, well, my unit, which takes an input and gives me a list, or a join function, which we'll look now. So yeah, like I said, the map function is just array map. The unit is just, well, return the value in square brackets. And the join is basically, well, if we have a list of lists and we want to get to a single list, well, we just basically want to like concatenate the lists together and return that. Which is basically, well, I want to merge all of the arrays that exist within my outer array. And having this join function, which is the second natural transformation, we can actually derive our bind function. So the bind function just, again, takes a function and associates it here with another closure, which is like, well, I'll concatenate all of the values from the array map that I get after applying my function. Now, why would you have a list of lists? Like, what is this case? Like, okay, like I map all of a list of products to a price, that's like a normal map, but how would I get a list of lists? Well, if we get it in action, let's say you have a product, but you want to suggest new products for people to buy. So from a product, you can get like some recommended products, which are a list for each individual product. Like let's say you can have a fancy version of this product, or a budget version of this product. Or if a certain brand has this product, well, you can have this product as well. And yeah, so if you bind this function to my array, like I get recommended products, and then I pass in my array to this function, and I dump this, I basically get a single list of all of the recommended product for like my cart. So yeah, that's one version of the monad. Next version. So yeah, warning, I did this with some side effects because laziness, and it just probably makes it clearer. And the point being here is that like you can use the concept of a monad from functional programming and slightly bend the rules to make it more easily to like implement in PHP, to make it more easily to use, to make it more useful for your use case. And one case is another one, which is like the logger monad, also known as the writer or the action monad, which carries some state around with itself. So let's say for every call, there is some log data that we want to track. And the bind function just says, okay, so I construct my logger monad, which has like my data, like the data I have, and with the logs associated to this. Well, the unit is basically just constructing this object with an empty array, because if you just have a value, what do you want to log with it? And the bind function calls this data with the function, and because it gives you a new logger monad, like the result, you have like the logs associated to this call. And you want to propagate the state from your previous logging state with the new logging state by just concatenating both lists together. So again, let's try to see it in action. So for this, I have a helper function which logifies my call, which just returns a closure, in this case, again, which takes a value and wraps it in an IDA function where the logging function is basically just, I ran this function with this value. And yeah, just return the new log on it. So let's say some actions to make it a bit more easier, like the thing with the piping, instead of needing to call bind every single time. I added a loop, which is the non-pure bit here, of just, well, I have all of my callables. I'm just going to map them with this logify function to get like a logging monad. I create my unit, which is, well, the initial value wrapped in a monad with no state. And then for each function which is now logging, I call it, and this is my new monad, and I loop through it. And here are some functions, pure functions that I added. So add 2, square, multiply by 3, divide by 6. So what happens if you log your calls, right? Well, I have my initial value 3, and I want to like call add 2 to it, square, multiply by 3, and I divide by 6. And my result of this whole logging call is a logging monad, for which I have the data, the final data, which is like, well, 12.5, if I start with 3. And then I can just like log all of the steps. It's like, well, I ran add 2 with the value of 3. I ran square with the value of 5, which is 3 plus 2. I ran multiply by 3 with 5. So, well, a square, well, 1 multiply by 3 was 25, which is 5 squared. And I divided the result of that, which is 75 by 6, which is 12.5. So yeah, that's actually the talk. I hope you actually had some examples of monads, which are probably clearer, hopefully, than just abstractly. And if you have any questions, feel free to ask. Or can we do questions, actually? Yeah, well, any questions about this? Examples? No. Oh, well. Oh, sorry. Yes. How is it related to? Nicely triples, okay. So this is the very technical bit. So the nicely triple is, if I go back to the beginning of my, well, let's just. So your nicely triple are so two of them are so one part is the category you're working on, which is, again, I'm not sure it's that useful, but the category would be all of the types that exist in PHP. So example, strings, integers, arrays, and everything. So that would be your category, which would be PHP types. And then you have your functor, which is thing is I always get confused by this, by actually what the case-free treble is, because that's not how I derived it. One part is the natural transformation, I'm pretty sure. And the second bit is how you, I think it's the endo functors, right? I don't remember. Actually, I don't remember here. I would need to go back and redo it and reread up on it. But yeah, sorry about this. It's the main. I think the main thing is you don't need to know about closely triples to actually use a monad in a programming sense. So yeah. Any other questions or not? I'm sorry. There's also a peak light here, so I can't really see you. So do shout or raise your hand very high or not. Well, if not, you can always come to talk to me at the end of the session, and happy conference.